Hi, I'm Clive Trott, and this is architecting an open data platform using Azure. So, okay, what we're going to do for the next hour-ish, might be a little less, might let you out a little early. We'll do some introductions, and I'm starting off on a high note, so I'm going to give the prizes out to start with. You've already had a drink and everything else, so hopefully my evaluations are going to be really good. Then we'll talk a little bit about Otago Regional Council and their open data platform, which is really what I've based this presentation on. And then we'll get into talking about building an open data platform. And then once we've spoken about the basics of an open data platform and what we do, we'll introduce Microsoft Azure and how we started to use that inside of ORC. So ORC is Otago Regional Council, just to make sure, and I might refer to an open data platform as an ODP, okay, just so you don't get lost. And then once we've spoken about Azure a little bit, we'll talk about some other considerations and some other bits and pieces around open data platform, and then we'll do some wrap up and hopefully we'll have time for some questions. No demo in there, but I have snuck one in for you, okay? Okay, so introductions. I really don't like presentations where the person stands up the front and says this is who I am and where I've been and what I've done. So I've done a couple of data visualization presentations, and I use this to get the audience to tell everybody else about me, okay? And this is where the prizes come in. So I'm not going to throw the prizes because that normally doesn't end well, okay? Especially these prizes, because we got some stainless steel water bottles, we got some pens, and now this prize is not open for people that know me, okay? If you can guess the one in the middle, or you know the one in the middle, yeah, yes, congratulations. Well, there you go. All right, so that one's gone. That was easy. Anything else? Anybody else want to tell me about me? Yes, you get a pen. That was easy. I do. That was really. You will have that. I'm not even going to give you that one because this is all branded theatre. Anything else? Yes, well done. That one I can get. Yes, well done. You get a bottle for that. Yep. Water bottle. There was that. I'm not going to throw it. See, I've got to have helpers. Two more. The water bottles are really, really good.
How can we get anything out of the lion?
Leo. Anything else?
Your name is Clive Trott.
I'll give you a pen just for saying it. One more. The water bottle. Yeah, I do have something to do with theatre. Yep, that's who I'm employed by. Anything else? Sorry? I don't like encryption. Well, yeah, we'll give that one away. Okay, that's good. So yeah, that's just a bit of fun, and just as I was saying before, basically the presentation goes downhill from now. Okay, so I want to start off talking about the ORC project and the architecture that we did for this. Now, unfortunately, I was going to make a couple of people stand up in the next couple of slides, but one of the guys has decided that he's not going to attend my presentation. That's Grant, who you saw on the if you were at the keynote on Tuesday. Grant Archibald, he was the guy in the video, and the other guy is Wayne, who's just down here. But basically, when we started the ORC project, this is what I did. Okay, like all good architects, you get up on the whiteboard, you draw some pretty pictures, you think it's going to be really cool and it's going to be really easy to do, okay, and then you give it over to people who actually do the work. And it really wasn't that easy. Despite my drawings, and I thought it was just draw some boxes, join them up, it'd be easy, okay? This is what we ended up with, okay? And this is a very, very sanitized version of this, okay? And there was a lot of stuff that we went through in order to get from here to here. Okay, and that's really what I'm going to talk about in this session. Okay, so what am I going to cover? All right, what is all this really boiled down to? Two major things that I'm going to cover, believe it or not, is data and infrastructure. Okay, because in this project they were the biggest things and the biggest issues that we had with. Okay, so that's what I'm really going to focus on. I'm also going to talk a little bit about security, a little bit about the services, and a little bit about the application that we used and that we created. Okay, now what I'm not going to cover in this presentation and at all is I'm not going to talk about presentation. Okay, I'm not going to talk about the business problems or the models. Okay, and I'm certainly not going to address the issue of why open data. Okay, just so that we're really clear about that. Okay, so any questions up to now? Or are we all good? Okay, I've given away all the free stuff, so no more questions. That's good. Okay, so let's talk a little bit about the open data platform basics. Okay, most organisations, or every organisation, has a series of applications, and behind those applications has a series of data. Okay, pretty standard on-premise applications with data behind them. Okay, doesn't matter what it's stored in, doesn't matter whether it's Oracle, SQL, Sybase, doesn't matter what the applications are written in, pretty standard stuff. Now, what we could just do really easily is go, well, hey look, we've got some databases. We'll just create a website. And we'll just pull the data directly out of those databases, and we've got our open data platform. Job done. That is possible. I wouldn't necessarily advise it, but it is possible. Okay? So you could do this. You could basically push out the data in tables of data, even provide the ability to download as CSVs. Okay? One of the issues around this, apart from all of the performance issues and you're going to hit your core applications and all those sorts of things, is one of the other things that you've got to think about is that you will only be able to present data from each individual database. So you're going to have no cross-database data sets and no cross-database consistency of the data. Okay? And this is where we're going to start to go with this data. The nice thing about this, though, is that all of your infrastructure you already have. Apart from maybe a website, you've got all of this. You don't need to add anything else. So that is a good reason why you would do this. So when I say infrastructure, I'm really going to hammer on this idea of space and disk space. Okay? So I just got a note on my slides here. There is a myth that disk is cheap. Okay? It is. You want to go down to Dick Smith's, you can buy a terabyte for, less than $100, which is great. But the problem is that good disk is not cheap. Okay? You want to go and put in, add a terabyte or 3 terabytes to your SAN, that's going to cost you quite a bit of money. Okay? So when we talk about this, and I'm going to talk about the data, you've got to think about, well, how much disk space am I actually going to need and where am I going to get that? Okay, so let's take a really, really simple first step, okay? And let's just put some sort of database that allows us to group our applications' data sources together, okay? Now, you could do this just by adding a series of views in a database that reference back to your core systems. That would work, okay? And put your website over the top of that. Okay? That would get round the issue of having, not having consistent data sources or merged data sources. You could do that quite easily. Okay? So that also provides you just one dedicated source for your open data platform. But again, you've still got load on your core systems, and it would still only work for really good really clean data sources. And I would suggest that that's only really going to work for database systems, okay, that you're using. So, what we have done, and part of my architecture, was to put in this thing called the data consolidation step, okay? And this is really the start of where we get into the architecture of actually, pushing forward an open data platform. Okay? So one of the things that you can do here, down at the bottom, we can start introducing different data sources. Okay? So we add the data consolidation step, and now we're not really concerned about just having databases in our open data platform. We can start pulling from flat files, we can start pulling from ODBC sources, and do other things. Okay? Now, one of the interesting things about the data consolidation step, which is not unique to open data platforms, it's more of a sort of any time you start pulling data, is about how do you get that data through? Okay? How do you understand either the updates that you've got to the data sources, or are you going to be pulling the data each time? And that's a really big thing that you need to think about. Okay, so architecturally, the core systems that you've got, could you put change data capture over the top of them? Right? If you can't, then does that mean that you're going to be pulling the data every time? Okay. And that has an effect on the processing time, it has effect on how much grunt you need, and all of those different things. So that's probably one of the first architectural things that we had. So the other interesting thing that we can get into here is metadata. This is where we can really start introducing the concept of metadata. The data consolidation step allows you to pull obviously the data about the metadata. When was the data last updated? Where's it actually coming from? And you can actually start adding that additional information. Now, believe it or not, that's really key. Okay, and a lot of open data platforms, that's what the users actually need in order to understand the data. Okay, and working with ORC, and we'll get into this a little later, the users and the people that are actually going to be using your open data platform are the people that you really need to satisfy. All right? And unfortunately, it starts at this step. And this is where you really need to start to understand that and start to think about how you're going to be presenting that data. So, so you can take your data consolidation step. Now, that could be SSIS, could be dare I say it, Westgate Red. It could be any technology that you want to use to basically do that data consolidation. Put it into a database, and then you can put your ODP website over the top of that. Okay, so now we're going to start talking about on-premise and the cloud. So this is where we really start getting into Azure and the difference between on-premise and the cloud. Now, just a quick note. When I talk about on-premise versus the cloud, I don't consider a data center that is local in your area the cloud. Okay? I still consider that to be on-premise. Okay? So basically what we've got here, got two axes. So one's your core applications and one's your open data platform. Bottom left, we're going to call this on-premise, and top right, we're going to call that in the cloud. Okay? So this is where everything has traditionally sat. Okay? You've traditionally had your applications, your core applications, sat on-premise, on servers that either you own or you're renting, but local to you. And traditionally, it made a lot of sense to keep your open data platform there. Why shift the data around when it's close? If you need extra disk space, traditionally it's been, let's just put it in our data center. Okay? So the next thing is to say, well, what happens if our core applications are in the cloud? Okay? Well, is it really likely that we're going to have core applications that are in the cloud and we're going to be pulling our data back from the cloud and putting it on-premise? Not really likely. I mean, if you've got your applications in the cloud, then you'd pretty much be wanting to keep the data there. So that's really not a likely scenario. So what we have now, and ORC is a classic example of that, of this, is your core applications are sat on-premise. Now, they could be sat on-premise for a number of reasons, either, just as a legacy thing. You've got your database is sat locally, or, you can't migrate an application to the cloud. That's one case for one lovely application that ORC had for us. There's just no way that it's going to go into the cloud. Okay? So there is always going to be this need, or potentially always going to be the need, to have something locally. Okay? So, but the idea is that, well, why not take advantage of the cloud? Why not take advantage of the cloud for doing your open data platform? Okay? So that's where we are heading now. Okay? But that's the future. More and more applications, more and more systems are moving to the cloud. I mean, we're talking about Azure now, and with the keynote and a lot of the sessions that are going on, we're talking about the cloud and the systems and the virtualization and the capability that you've got. And the question that I keep asking myself is, why wouldn't you put stuff in the cloud? Anybody got a decent answer for that? Because, sorry?
Privacy Act.
Privacy Act. Yep, that's not a bad answer. Yeah. So yeah, privacy is one, security is another. And there are performance. Okay. So do you reckon that you could get better performance having servers locally than you could in Azure? Okay. Latency, yeah, I'll give you. Okay, but performance of an app, I don't know. Okay. So yeah, there are some reasons, but I mean, I really do think that where Azure is going and where Microsoft are going and Amazon and everybody else, moving to the cloud is where it's going to be. So having your core apps in the cloud, having your open data platform in the cloud, that's where it's really going, and that's where it's heading. So, yeah. Okay. So, this is the sort of the data consolidation step that we had, that I showed you before. The next sort of architectural challenge, or the next interesting thing to talk about, is where do you draw the line? What do you put in the cloud? Okay? So, you could say, I'm just going to put everything in the cloud. Everything from my core systems up, I'm going to put in the cloud. Okay? That's okay, but what happens if you've got flat files, or you've got an ODBC source, or you've got something that doesn't necessarily work, and you don't have the capability of basically pushing that information up into the cloud? So what you could say is, okay, well, we'll do the data consolidation step, the processing of the data locally, and then we'll push the data up into the cloud, up onto a database inside of Azure, and go from there. That's okay, but where we got to with ORC, and for other reasons that I will talk about in a little bit, is that we actually had to have some of the data stored locally. Okay, and I'll explain that in the next slide actually. So a couple of things to think about when you're thinking about drawing that line. Cost. So, I spoke about how disk is not cheap. I sort of tried to debunk that myth. If you're going to do processing locally and you're actually going to store some stuff locally, that means that you've actually got to go out and buy that new disk. Now, one of the things that we did with ORC is that we actually took a slight data warehousing approach to pulling the data out. Now, when you start doing that and you start thinking about how many copies of the data that you need, okay, you're looking at potentially 2 or 3 versions or 2 or 3 copies of that data at a particular time. And that means that you need 2 or 3 sets of disk in order to deal with that, okay? So there is a cost. Now, do you want to put that locally? Do you want to spend that money locally, or do you just want to, buy it in Azure, okay? So you've got a potentially free. I mean, there is a potentially free situation here. You could have a whole bunch of servers that come free in your organization. You say, well, what do I do? Do I just decommission these, or do I use them to start my open data platform? That could be a good thing to do. Okay? So, power. We're talking about performance, and we're talking about different things. When you start talking about power and the capability of machines, you might have some tin either in your organization or in a data center, and you start using that. I would suggest that you are going to have a limited amount of capability and a limited amount of power that you're going to get to. When you put it in Azure, well, if you need more power, if you need more IOPS or whatever, you can just ramp everything up, add more cores, even if you're going to do it using virtual machines. You can just increase the power to whatever you need. Okay? So again, you've got that trade-off to think about. The other interesting thing is the capability. I won't talk about virtualizing SQL in Azure on virtual machines, but if we just talk about the SQL capability in Azure, that's not a full capability. You don't have access to all of the SQL capability that you do if you put it on a virtual machine locally. Okay? So that's something else that you need to think about. Is there something that you need inside of SQL that SQL Azure doesn't give you? Okay? Luckily, we didn't. So that was good for ORC. Okay. So, talking about, in the previous slide, I said I'd talk about why, for ORC, we had to draw the line where we did, okay? And it comes down to data migration, okay? There are 2 factors that you've really got to take into consideration around data migration, okay? And one is the frequency of the update, and secondly is the size of the data that you're actually updating. And I spoke about this right at the start, and we were talking about capturing how the data changes. Okay, if you've got a system that you can't put something like CDC on or capture just the changes since you last did an update, and you're going to have to do a full upload every time, that's going to potentially be a lot of data and a lot of time to do that. So what you might actually want to do is you might want to say, well, I'm going to put an intermediary step in and allow me to store stuff locally that then I can put a CDC over so that I'm only actually sending the updates through to Azure. Okay? Which is what we did for ORC. So taking into consideration these 2 things, for ORC we used 2 different mechanisms for getting the data up into Azure. So the first one was the Microsoft Data Sync Services. So this is a transactional-based update. It's really good for small amounts of data, but done very, very frequently. Okay? Now, ORC have a business requirement that they get updates for their river flows every 15 minutes. And they want to make sure that effectively on the 16th minute after we get an update, that information is pushed up into Azure so that people can actually look at it, because people use that information that quickly to understand, is the river about to flood, do I have to move cattle, all of those sorts of things. So having that updated really frequently was really important. So the Microsoft Data Sync Services uses triggers on the client and the server, and a series of tracking changes to know what's changed and basically push the changes up into Azure. There are some limitations with this. The Microsoft Data Sync Services does not currently support geospatial data types. It's a small issue. Okay. I don't know whether that's going to change, but I'm sure it will at some point. The other issue is that if you are changing your data structures frequently, then there's an amount of work that you have to go through to deprovision the tables that are inside of the data sync services and then reprovision them. Okay, so it's not something that you would necessarily have business users doing. Okay, so they're the two issues, but it's very good for that, low volume, high frequency type stuff. Now, the other process that we used was SQL Azure Migration Wizard, okay, which is an open source project. Now, this provides effectively the exact opposite of the data sync services. It's really good for high volume but low frequency. Okay, so it allows and it provides a mechanism to do table-to-table migrations. So you can do it from on-premise, obviously, up to Azure. Sorry, just going to grab another water. Now, the process behind the Migration Wizard, or the open source project, it does a bulk upload. And it basically takes a snapshot of the table and then migrates it into the new environment that you want. So one of the things that we did in order to ensure, one, no data loss, and two, no loss of connection for ORC, was that we basically did a copy of the data up into a different table and then basically pointed the connection to the new table and then removed the old one. Okay? That was a really good way of making sure that the system is always constantly giving you a response, or the web app is giving you a response. So the open source project uses SQL bulk copy. It does have transactional support, and it batches the data under the hood. So it is a very good solution. One of the downsides of this, though, is that you can only do table-to-table migrations. So what we did for ORC was that we actually put in, we copied data from a view into a temporary table and then did the migration on the temporary table. So that allows us to get around that issue of it only being tables, because we use a lot of views in what we do. Again, what I'm going to talk about this is that, again, if you think about it, what I've been talking about is you've got multiple copies of the data. Okay? So even me just saying we copy the data from a view into a temporary table, if you can imagine, if you're doing a bulk copy with 54 million lines, okay, with X number of attributes, you're going to have the disk space, okay, to do that. Okay. So I just want to touch, I'm going to continue talking about data. I just want to touch a little bit about how you structure the data for users. So a lot of the time, people just go, hey, I've got a transactional system. open data platform, people want to see all of the data. So we're just going to dump all of the data up onto the open data platform and, off you go. All good. Now, there are basically three things that I feel are always going to be in your data. What, when, and where. Now, I know that there are other attributes that you're going to have in your data, but I challenge myself to think about a data source that doesn't have at least those three things. Okay, and I couldn't come up with one, but, hey. So, and most people will think about their data in an organization by one of those things. Okay? So, in ORC, it was very evident that they thought about their data by what. So they talked about data being river flow, rainfall, temperature, air pollution. And basically when we were talking about data, we were always talking about what. And we were carving our data sets up by what. Okay? But the data, obviously, had when, so it had a whole bunch of dates. Obviously, it was some of the river flow data was being taken every 15 minutes. But it also had a where. They had basically stations that they collected this data from. And one of the things that, while I was working on the project, was that I suddenly had an epiphany is that you've got to think about slicing your data differently. Okay? So rather than providing, just rainfall or river flow or, air temperature, what about slicing it by a location? So by where? Okay? Slice it by that and provide all of the attributes. So provide the river flow, the rainfall, and doing it that way. So one of the things that I want to get across in this slide is the importance of trying to think of using your open data platform the way that a user is going to, and then structure your data accordingly. Okay? Now, people can think about data in any way. And again, one of the things that we've done with ORC and one of the reasons that we've done the open data platform is so that people can just take the raw data and do stuff with it, which is really good. Okay? But also there are going to be the casual users that are going to want to come in and just do some stuff, and they're the people that you really got to sort of think about. Cool. Okay. Mostly men in the room. It is important. Okay? Don't care what anybody says. So, carrying on from that conversation about structuring the data, you don't know what the users want, okay? You don't know what they need. Now, interestingly, I was at the keynote and something that Sean Gourley said was really interesting when he was talking about when you search on Google and you get, 4,500 articles, right? And it would take you forever just to sit there and read them. Well, that sort of rung true with me a little bit about when you go to an open data platform, or you go to any site actually, and you go, I want to look at this data, and it gives you back 50, 100,000 rows. You're not going to look at that data, okay? So you've got to think about how you're going to present that and how you're going to structure it. Now, I just did some really simple calculations for ORC. So 39 sites, okay, and you've got a data collection point every 15 minutes. So that's 4 an hour, 96 96 data points per day, close to 3,800 a year, close to 27,000 per week, and 1.4 million a year, just on one site for one data point. Okay. Now this isn't big data. Don't get me wrong. This is seriously not big data. Okay. But if you then say, if somebody comes along and goes, I want to give me all of the data that for one site for 1 year for rainfall, you're going to be getting back 1.4 million rows. Okay? Most people's browsers and PCs are not going to be able to deal with that. Okay? So you've got to think about how you chunk that data up and how you display it. Okay? If you then said, one of the things that we have with ORC is that they've got 40 years of historical data. So if you just take one site, you say 1.4 million rows with 40 years, you're now talking about 54 million rows of data. Okay? So you've got to think about, the size of the data and how it's going to come across. So one of the nice things about this, though, is that SQL Azure does provide you with the capability to scale as you need. Okay? So what we've done for ORC and how we've provided that data, when they start bringing on extra data sources, we can easily scale out to provide the bandwidth and the size that they need. Okay, so I just want to talk a little bit about the Azure data storage. So basically we ended up using SQL Azure for the ORC. Okay. Obviously you know about SQL Azure, I'm not really going to go over that. But for an ODP, it provided us some really key points. It provided us with a well-known and structured process. It actually provided us an easier process for the transition of data. And it required a full application layer and an easy application layer on top. It was actually well known. Now, the other option that we had, and believe it or not, what we started out using was table storage. Okay? So, again, I'm not going to talk about what table storage is, but for the ODP, we started out using it for exactly those reasons, right? It was easy to put large amounts of data into it. Obviously, you've got a 200 terabyte versus 150 gigs, okay? However, the data was denormalized, which presented us with some problems. However, and this was the big sticking point, or the reason that we used it and we had problems moving away from it, is that you get native OData from table storage, okay? And we built the whole of this project around the OData services, okay? So we started off and we actually used an open source solution as the application front end, and that included table storage. And that I'll take you right back to my my original slide where I was drawing everything up on the whiteboard, and it was just, for me, it was just some storage. I just put a box in there and said, well, we'll just do some storage in there and we'll put it in Azure, okay? Then when the techie guys got hold of it, they were like, oh, well, we've got this open source system, it all works, and it uses table storage, and that was all good. And then we suddenly realized, and there were a few points that we hit that went, we can't use that anymore, we have to move to this, okay? So if you want any more information about that, I'm more than happy to talk about it offline. So, moving away from data and infrastructure, talking a little bit more about some of the other aspects that we had, that we were doing inside of ORC, and things to think about for open data, an open data platform. So, security. Now, when I first heard that requirement, I was a little puzzled. Open data platform, open. You're meant to be providing it for everybody. So why do we need security? I was challenged on that. And to a certain degree, ORC, and I can understand this, wanted to know for certain data sets or for certain attributes of data sets who was actually getting it. And they wanted to be able to control that, okay? Which is fine. I mean, it becomes it's just a requirement, okay? So, after I got over my little hurdle, we ended up having basically three sets of users. Internal users, unknown external, and known external. Now, one of the things that, again, ORC wanted to do was that the open data platform was going to be used not just by external people, but all of their internal people. It would be the place that they go to find information if they had a request. Okay? So that was another really key point to the ORC project, and it was, you know, a very bold move that they're going to actually make their users eat their own dog food. It's very good. So the first thing that we had to deal with was authentication. Now, one of the things that we wanted to do was single sign-on for all of our internal users. We didn't quite get there. I'm sure we will be in the future. So one of the things that you can do, though, obviously Azure Active Directory, and having the ability to synchronize between on-premise and Azure would be the way to go with that. Okay, so that would be one of the things that we'll probably be looking at to do. So one of the things also that we wanted to do with our known external users was that we didn't want to put in any authentication mechanism. We weren't going to be putting in usernames and passwords and dealing with all of that goes around it. We wanted to use the authentication capability that was already out there. So we sort of, for some bizarre reason, settled on Microsoft Live IDs. And basically we used the OAuth protocol for doing that, or the authentication. So once we've got them authenticated, the next thing was the authorization. And we kept that completely separate. And I know that bottom statement is really silly. It can be simple or complex. But, you know, it can be. It's all based on your requirements, okay? You can make it really, really simple and just go, okay, you know, you just get access to these data sets. Or you can make it really, really complex by going not just data sets, but you can do attributes, and you could theoretically do row-level security on data sets as well, okay? So that is really driven by the requirements, okay? But, you know, the application and the open data, open source project that we use had all of that capability. Okay. I'm not going to talk a lot about the services, the open data services. I'm not an expert. There's a session I've got it at the end. Grant Archibald's got a session about Web API. If you're really interested, go to that session and talk to him, because he's really, really good at this stuff. But basically, the OData was the core of our whole application, the application layer. Now, we did struggle with OData a little bit. The current version of OData is untyped, which I'm not going to get into, and it's currently static. So with OData at the moment, what you have to do is that you have to define everything, compile it, and then it works. Okay. So what you can't do then is you can't then change your data types underneath the hood. Okay. One of the things that we did on this project, and we are actually looking to give back to the community around OData, and Grant is looking to give that back to Microsoft, is actually we changed it, or Grant, I say we, Grant did this, is to allow it to have untyped versions of data inside of OData. So that means that at runtime, the OData actually picks up the data types, so that what that means is that the users can go in and change the data types and change the data sets, and we don't have to recompile the code. So that was a really nice addition to the capability. The other thing that we have done was the geospatial data, geospatial queries for OData. They didn't exist, but it was really an important part of our solution, so we had to put that through. Okay. So, talk a little bit about the application. We just used the bog standard Azure web roles for our web application. As I said, it was a open source project that we used to do this. It's called the OGDI. Please go and look it up. So one of the things that we wanted to do was actually have a really dynamic solution for ORC, as I was saying, so that basically we could define, if the business wanted to add an additional data set, they could do it without involving the developers. Okay? And it's a really nice requirement, and it sounds really easy, but it's not. Okay? But we've done it, and it works really, really well. So what we have on the solution is we have tabular and graph data. We have the ability to do exporting of that data in multiple different formats. And we have maps and geospatial data. Okay. So, just one note about the geospatial data. In New Zealand, it's not easy to use big maps with the geospatial data that we have, okay? We thought it was going to be really easy, and we gave it, and we just plotted a whole bunch of data and gave it to the guys down at ORC, and they sent it back going, no, it's all wrong. Which wasn't my best day ever on the project. So one of the things that we've actually implemented for ORC is that we're using all of their Esri map services to get all of their tiles for their area. Okay. Now, I believe that we've done some funky stuff to do the coordinate migration or calculations to put it into the correct coordinate systems and the correct projections so that we've got both. But one of the things that I would suggest is that if you are going to be doing an open data platform and you're going to have geospatial data, you need to find a very, very good New Zealand version of maps. Okay? Bing doesn't really cut it. So, sorry, Microsoft. Okay. So, basically, I've covered pretty much everything that stands up there. Yeah. So what I'm going to do, I want to do is really quickly, I'm just going to give you a really quick demo as we have time. We do have time. A really quick demo of ORC. And I want to just show you a couple of things about some of the data aspects. You can see? Excellent. Welcome to ORC Open Data Platform. Would I say this is the first in New Zealand for regional councils? Yep. Sorry, Robert's over there. So yes. So yeah, this is a real first for New Zealand. And it is live. Just ignore the test down there. Somebody's got to do a bit of cleaning up, and it's not me. Okay, so I just want to pick on this, and I just want to show you some stuff. So basically, what we're looking here is the consents that ORC have for their area, and as you can see down here, we've got the map and the bar chart and time series charts. We won't get into that. And what we've got here, and this is what I'm talking when I was talking about how you present the data. This is a really good example of it. So what we've got here is that, and what I've just opened is this is current consents, submitted in 2012. Okay, so this is a really narrow view of the vast amount of data that they've got. Okay. But as a user, I'm coming in here and I'm looking at this, and I go, cool, well, I've only got 1,113 data points, okay? So when I click on a map, and this is where it all goes horribly wrong. Oh, not bad, okay? It's pretty quick to come back, okay? And, you can see the different types, and it's nice. And you can go, well, okay, now I want a bar chart, and I just want to go permit category, and I can refresh the data, and it's relatively quick. Now, as an end user experience, and this isn't really to do with the architecture of the solution in terms of Azure, but it's more the architecture of the data, okay? That's a really good experience for me because I can see something, it's snappy and it's quick, okay? If I go back here, all right, I've got, 141,000 records, okay? I go, well, I'm just going to do exactly the same bar chart. Now, believe me, this does come back, okay? But it certainly doesn't come back in the same time frame as the other data and as the other way, because again, I mean, it's just pure numbers, okay? And the amount of data that you're transferring and all of those sorts of things. See, I told you it came back, okay? So I think the biggest thing that I took out of the ORC project around architecture is around the data architecture rather than anything else, okay? I mean, we were using standard Azure SQL. We've not done anything really differently about it. We're using standard Azure web roles, and we're using a lot of the standard stuff. We have done some stuff around OData, and we've changed some stuff. But architecting that data and getting that data right is the real key, okay? So we've actually had to limit, you might see here at the top, maximum download limit for CSV files is 50,000, okay? Just purely because, the system just can't handle actually doing any more than that. Everything times out. So, yeah, that's a really good example of that data architecture, and coming back to, that whole thing about size is important. It really is. Okay. So, just going to wrap up. So, from a learnings point of view, as I was saying, data. Getting those data sets right, looking at the data consolidation, thinking about all of those things is really important, okay? Get that right and everything else becomes easy. Data transfers, okay? Those data sync services and the bulk uploads, understanding the requirements around, how often you're going to sync and how much you're going to sync, again, has an impact on the architecture, has an impact on, where you're going to do it locally, in the cloud, all of those sorts of things. So that's really important. Storage in the cloud, SQL versus table. They're some of the learnings that we've taken away. Table storage is great for doing some stuff, but it does have its limitations, and sometimes you just want SQL, okay? And there's no getting away from that. And that whole issue around geospatial content, getting it and viewing it, that's probably the four major issues or learnings that I've taken away from the ORC project. And if I had to, when I do the next one at some point, this is what I will be focusing on. Okay. Questions? Anybody got any questions for me? Yes?
Did you consider elementary data instead of like status of X1?
Sorry, so the question is, did we consider using...
elementary information, like instead of word X, like 1.
Okay, so I suppose the question is, did we think about using a status? So your example is use 1 rather than active and 0. So yeah. So obviously doing those sorts of things would cut down the amount of data that you're actually pushing. But on the flip side of that, you've got to think about how people are going to use it. Yeah? What does it actually mean, and will people use it? And, the interesting thing is that there are a lot of people in this room that would understand that and get on with it and, wouldn't even bat an eyelid. But then that's not what we're developing for. We're developing for people that are going to use this system that don't understand that 1 means true and 0 means false, okay? And also that you've also got that issue of having to then educate people and put that information out and do that. But yeah, those sorts of things would decrease the amount of data that you're actually having to push around and store. That's all right? Yes?
Did you do anything to ensure that any changes to the applications was also reflected in your data aggregation layer? So any logic change in the applications that you used were correct?
So the question is, did we do anything in the application layer?
No.
Oh,
To handle any change in the application layer that might change your logic around your data, that it's also reflected in your data aggregation?
the short answer to that question is no. The application is actually really quite dumb. It basically just displays the data. So one of the things that we have done in the solution is put a whole metadata solution together. So the application actually reads the metadata for the data sources and then just displays that. So the application doesn't have any really logic around the data sets. It's the data sets that drive the application. Does that answer your question? Yeah? Yeah.
Are there any challenges, in terms of the AI solution because they have the cloud?
BI.
The BI solution, like the reporting,
So is there? So I think so. Yeah. So the question is there any challenges around from a BI solution and users being able to visualize that data? So no, there aren't any issues around people being able to visualize it because it's in the cloud. We actually use custom controls for doing the charting, and we used some Azure controls for doing the mapping. But no, there's no. The other interesting thing about an open data platform is it's not a reporting platform. So you want to be able to provide people with a way of being able to view the data. So as you saw, you can look at it from a tabular point of view, or be able to chart it or graph it. But you've got to draw that line, and drawing that line is really interesting. How much visualization do you put on an open data platform, and how much of it do you just leave for people to download the data and do their own visualizations? Okay, and that's a really fine line of where you draw that. Yeah.
So they're thinking of having the data warehouse over this data?
No. So the question is there going to be a data warehouse over this data? And the answer to that is no. This is purely the raw data so that other people can do stuff with it. Yes?
What's the decision to use SQL because it's easy to query? What's the main driver?
Yeah, so the question is, what was the main driver for using SQL? There was a very, very good reason for using it. I just can't remember. No, well, so the OGDI, when we got it out of the box, was just table storage all the way. I think the issue that we were having is getting the data up into table storage. So we were talking about how you do that data migration and having frequency of updates or being able to do bulk updates. With the OGDI and the solution and table storage, they just provided you one mechanism, and that was it. So that's why we actually switched over to SQL, so that we could actually do, very, very fast updates of the data. I think that's why. Yes?
I'm curious about historical data. Is there an as-at sort of feature? So if I pull down the data of last Friday, and there were updates in the system up till now, will I be able to see that between data as at Friday and as at now?
So the question is there an as-at capability of the data? So yeah, all of the data has got metadata associated with it, so you can actually understand when the data was last updated. I don't know whether we've done it at the row level, so you could see the different things, but you can definitely do it by the data set.
Does that make big storage applications?
No. Yes?
Have you provided the capability for users to subscribe to a data feed and automate consumption of what you provide?
Yep, so we basically provide, so the application uses OData feeds, and we've also published those OData feeds as well. So anybody can subscribe to those OData feeds and do what they like with them and put automation and draw the data down however they like. So that was one of the driving factors behind the whole project, was to allow third parties to have access to the data so they can do what they like with it. So yes, we have provided that mechanism, and that's there. That's that capability. Yep. So the question is that have we looked at users supplying their own data? No. And I don't think I really want to. Yes.
So you give no external users different privileges from unknown ones, for example, access to data sets or more ability to pull down data and contract?
Yep. So the question is that do we give different permissions to the unknown and the known? And the answer is yes, very much so. So we actually give, they have access to different and a larger set of data sets, and also there are attributes on some data sets that known users actually can see. So the way that it works is that you can log in, and if you have a live account, you can just go in, or it will create one for you. And then once you're there, then you can email ORC and say, I'm a known user, I want to look at this data, or what data do I have available? Yep. Yep.
What was the main motivation to stick with Azure for you again? I mean, looking at the final architecture, it doesn't look like you really need any of the Azure-specific features there. It looks like something to do down the road, any data hosted in New Zealand.
Yep.
Big data being transferred to Singapore or wherever you have hosted. It doesn't outweigh the disadvantages of shifting all that big data.
Yep. So the question is that, why do we go Azure, effectively? So the reason that we really went Azure is because ORC didn't want to carry the tin anymore. They had a requirement to basically get rid of the tin locally. They didn't want to carry that, and they didn't want to have to worry about, when they moved to their data center, they didn't want to have to worry about the open data platform and trying to provide capability and storage for that. So that was why we went to Azure, because it's got the capability to store all the data, to grow as we need it to grow, and the capability. Not that we wanted to go down. So, yes.
I have two questions for you. First thing about the untyped data. Don't you have the security risk around untyped data because you are trying to replicate what stable data does? And the second one is regarding why not use Hadoop and generate most of the stats from permission. So you can overcome the limitations of the data and those with the CSV.
Both very, very good questions. If you'd like to come up afterwards, I'll come and talk to you about them. Any other questions? Because I think we've run out of time. No? All right, well, thank you very much.